Hi, this video is about async job queue. We are now in the production layer. This video solves one of the first problems you will hit when you deploy an AI feature to real users. LLM calls are slow, and you cannot block your web server waiting for them. So what is it? Here is the problem. A language model API call can take anywhere from a few seconds to a full minute for complex tasks. If your FastAPI handler blocks while waiting for the response, the server thread is tied up doing absolutely nothing for that entire duration. A thread is a unit of execution in your server process. Think of it as one worker who can only handle one task at a time. When that thread is blocked waiting for the LLM, it cannot handle any other incoming requests. Under real traffic load, all your threads fill up quickly. New requests queue behind each other. Eventually, HTTP connections start timing out, meaning clients give up waiting and receive an error. An async job queue solves this with a pattern you may already know from video encoding or email sending. Instead of waiting for the slow work inside the HTTP handler, you hand the task off to a separate background process and return immediately. The 5-step flow is: the user sends a request, your API enqueues the task instantly, you return a job identifier to the user in under 50 milliseconds, a background worker picks up the task and runs the LLM call, and the client pulls a status endpoint to check when it is done. The drive-through analogy makes this click. The bad approach is the cashier cooking the burger himself. Every customer waits 10 minutes, and everyone behind them waits too. The good approach is the cashier taking the order and handing over a receipt number. The kitchen makes the food. The cashier stays fast. The kitchen does the slow work. Next is workflow. The workflow has 9 steps across 2 rows. The submit row covers steps 1 through 5. Step 1. The user sends a post request to the analyze endpoint. Step 2. The endpoint calls task.delay with the prompt. This is Celery's method for enqueuing a task. Delay is named after the idea that the actual work is delayed to run later. It puts the job on the Redis queue and returns immediately. Step 3. The endpoint returns the job identifier in under 50 milliseconds. The HTTP request is complete. The user has their receipt. Step 4. A Celery worker running in a separate process picks up the job from the Redis queue and calls the LLM. Step 5. When the LLM finishes, the worker stores the result in Redis. The poll row covers steps 6 through 9. Step 6. The client calls get/status with the job identifier, typically every 2 seconds. Step 7. The endpoint checks Redis. Step 8. If the job is still running, it returns a processing status, and the client tries again in 2 seconds. Step 9. When the job is complete, it returns the result, and the client displays it. The green complete box at the end of the poll row is the happy path. The user gets their result, the polling stops, and the connection closes. The tip at the bottom mentions WebSockets as a better alternative to polling. A WebSocket is a persistent two-way connection between client and server. Instead of the client checking repeatedly, the server pushes the result the moment it is ready. We cover this on slide 9. Next is key concepts. 3 components to understand. First, FastAPI, the cashier. It has 2 endpoints. The enqueue endpoint receives the prompt, calls task.delay, and returns the job identifier. It never waits for the LLM. The status endpoint takes a job identifier, looks it up in Redis, and returns the current state, either queued, processing, complete, or failed. It also returns the result when complete. Second, Celery plus Redis, the kitchen. Celery is a distributed task queue library for Python. Distributed means tasks can be picked up and run by workers on any machine, not just the one running your web server. Each Celery worker is a separate process that handles one job at a time. You can add more workers to handle more concurrent jobs. Redis plays 2 roles here. As the broker, it holds the queue of waiting jobs. As the backend, it stores the results of completed jobs. Concurrency, set with the concurrency flag, controls how many jobs a single worker process handles simultaneously. Third, polling versus WebSockets. Polling means the client repeatedly calls the status endpoint at a fixed interval, typically every 2 seconds. It is simple to implement and works with any HTTP client. The downside is a delay of 0 to 2 seconds between when the job completes and when the client finds out. WebSockets eliminate that delay by keeping a persistent connection open. The server pushes the result the instant it is ready. Start with polling during development and upgrade to WebSockets when you want a better user experience. Next, project setup. Install Celery, Redis, FastAPI, Uvicorn, Pydantic, Python.env, and Anthropic. Start Redis using Docker. The command runs a lightweight Alpine-based Redis container and maps port 6379 on your machine to port 6379 inside the container. Port 6379 is Redis's default port. Verify Redis is running by calling Redis CLI ping in a new terminal. It should print pong. You need 3 terminal windows. Terminal 1 has Redis already running in Docker. Terminal 2 runs the Celery worker. Terminal 3 runs the FastAPI server. You must start them in this order: Redis first, then workers, then FastAPI. Next, tasks.py. This file defines the Celery application and the task function. The Celery constructor takes 3 things: the application name, a string used for identifying this Celery application; the broker URL, pointing to Redis database 0, which holds the job queue; the backend URL, pointing to Redis database 1, which holds the results. Using separate database numbers for broker and backend prevents them from interfering with each other. Redis supports 16 databases numbered 0 through 15 by default. The configuration update sets several important options. The result expire setting controls how long completed results stay in Redis before being automatically deleted. 1 hour by default. The worker prefetch multiplier set to 1 means each worker picks up 1 job at a time, rather than grabbing multiple jobs and potentially starving other workers. The task decorator has 2 important parameters. Time limit of 120 seconds means Celery will forcibly terminate the task if it takes longer than 2 minutes. Max retries of 2 means if the task raises an exception, Celery will automatically retry it up to 2 times with a 5-second delay between attempts. The retry is triggered by calling self.retry inside the accept block. The bind equals true parameter makes the first argument to the task function, the task instance itself, available as self. This is needed to call self.retry. Next, main.py. The FastAPI application has 3 endpoints. The enqueue endpoint accepts a prompt and calls run_LLM_task.delay with that prompt. The delay method is non-blocking. It puts the job on the queue and returns a task object immediately. You read the task identifier from task.id and return it in the status response. The status endpoint takes a job identifier as a path parameter. It creates an async result object, which is Celery's way of looking up a task by its identifier without waiting for it. Async result is a non-blocking reference to a task. You can check its state and result without waiting. The task state field can be pending, which means the job is queued but not yet picked up, or started, which means a worker is currently running it. Success means it completed successfully. Failure means it raised an exception that was not retried. Retry means it failed and is waiting to be retried. The cancel endpoint calls revoke with terminate equals true, which sends a signal to the worker to stop the task immediately if it is currently running. Next, client polling. The Python client has 2 steps. First, it submits the job with a post request and stores the job identifier from the response. Second, it enters a while loop that calls the status endpoint every 2 seconds. When the status field is complete, it returns the result. When the status is failed, it raises an exception. The curl test on the right side lets you verify both endpoints from the terminal without writing any code. Submit the job with the first command. Get the job identifier from the response. Then pull the status endpoint using that identifier. The FastAPI docs page at localhost:8000/docs gives you an auto-generated interactive interface where you can try both endpoints from your browser. This is useful for quick manual testing. Next, WebSockets. The WebSocket endpoint accepts a connection, then loops every 500 milliseconds, checking whether the task is complete. When the task state is success, it sends the result as a JSON message and closes the connection. When the state is failure, it sends the error and closes. A WebSocket connection is established using the JavaScript WebSocket constructor, passing the URL with the ws://protocol prefix and the job identifier as a path parameter. The onMessage handler receives each JSON message. When status is complete, you display the result and close the WebSocket. The key advantage over polling is the check interval. The WebSocket endpoint checks every 500 milliseconds internally, so the result reaches the client within half a second of completion. Polling at 2-second intervals adds an average of 1 second of extra waiting. Next, agent task as background job. This slide shows how to run a full agentic loop from Video 7 as a Celery background task. The only change from the agent code you already wrote is wrapping it in a Celery task decorator with a longer time limit. Because agents can call many tools and take several minutes, the time limit is set to 300 seconds, 5 minutes. If your agents regularly take longer, increase this value. The log list records every tool call the agent made, which tool name, and what result it returned. This is included in the task result so the client can see exactly what the agent did to produce the answer. This combination, agents as background Celery tasks, is how you build production AI systems that handle long-running autonomous tasks without blocking your web server. Next, common errors. 7 errors to know. If you get a connection refused error, Redis is not running. Start it with Docker and verify with Redis CLI ping. If the status always shows queued and never moves to processing, the Celery worker is not running. Open a new terminal, activate your virtual environment, and start the worker. If the task status stays in pending forever, your result backend is not correctly configured. Check that the backend parameter in your Celery constructor matches the backend parameter. If the worker crashes with an authentication error, it cannot read your API key. Add load.env at the top of tasks.py before creating the Anthropic client. If a task silently disappears, the time limit was exceeded. Increase it with the time_limit parameter on the task decorator. If you get a module not found error in the worker, your virtual environment is not activated in the terminal where you started the worker. Activate it and restart. If a WebSocket connection closes immediately, the job identifier does not exist in Redis. You must submit the job first with the post endpoint and use the returned identifier. Next, takeaways. Never block an HTTP handler waiting for a slow LLM call. If the call takes more than a second or two, put it in a background queue. FastAPI enqueues the task and returns the job identifier in under 50 milliseconds. Celery workers run the actual LLM call in separate processes. Redis plays 2 roles. Broker holds the job queue, and backend stores the completed results. 1 tool, 2 purposes. Start with polling every 2 seconds. It is simple and reliable. Upgrade to WebSockets when you want results delivered in under 1 second of completion. The same pattern works for agent tasks from Video 7. Just increase time limit to 300 seconds or more, and include a log of every tool call in the result. Next video is guardrails, where you add safety checkpoints before and after the LLM.